Good afternoon, folks. My name is Nathan Kalosa-Kenyon. I'm the owner and founder over here at Canosa Consulting, and today I will be bringing you part two of the FPDS data pipeline series. This video has a couple prerequisites. One, we will be talking about RunPod and Modal, which are hardware rental services or applications. We will be talking about BERTopic, which is a topic modeling machine learning algorithm that is used by some of the world's leading companies and even government agencies like the Department of Homeland Security, as you see here. Also, this video assumes that you have already watched our pre-embedding pipeline video, where we go over the processes and procedures, methods, and techniques that we use to process text data before it goes into our unified embedding space. And it also assumes you know what this unified embedding space is, what it represents, and the purpose that it serves in our system. So I'll hop right in. After we get our unified embedding space, we pass different segments of embeddings to our topic model pipeline. And the reason for that is there is different language used in each of these different buckets of text data. So there's different language used when describing government contracting from a news perspective. There's different language used in executive orders, FOIA documents, award descriptions, .gov.mil websites, strategy plans, the list goes on. Since we know that there's differences in languages, we break it up by those different segments. Those are listed here. You can pause the video if you want to take a peek at those. I will also allow the audience to take a peek and pause the video if you want to read the purpose and overview of this topic modeling stage if you would like. Now, it is important to note that this topic model pipeline is the diagram is built from our V2 system. This does not represent the full capabilities of the FPDS topic model pipeline, as our V3 and V4 are currently in progress. Now, to begin, in BERTopic, if you're going to use it out of the box, right, you're going to install the dependencies and you're going to use this application, it will create a set of embeddings for you. So say you have a comment section from your TikTok video or advertisement and you want to know what people are talking about in the comments, but you can't read every single one. You use BERTopic modeling to discover what people are talking about generally within that, corpus, corpus just means that body of documents that you are modeling. So BERTopic will create those embeddings for you, but since we already have our unified embedding space, we just use our own. So we pull the segment of our pre-computed embeddings into the topic model pipeline that's hosted on RunPod using a Docker image, and then the next step is deduplication. But if you watch the last video, you know that our unified embedding space is pretty clean because we do this post-embedding cleaning using cosine similarity, which is practically the same method and technique that is used here in this deduplication step. However, if it's the first time that we're modeling a certain agency, we do it as a quality assurance pass. Now we configure the algorithms that we're using. We configure the parameters for UMAP and HBD scan, which are part of this BERTopic stack, as you can see here, and that tokenizer algorithm as well. And then we do our pre-flight checks, which just means, is our corpus deduplicated? Did we, correct the right parameters? Sometimes we'll make a call to a model to do this. We'll say, is this set up correctly? Most of the time we don't. We have a pretty confident pre-built ratio depending on the document sizes and volume of documents or quantity of documents, as well as their density, meaning the amount of characters or words within a document. Then the BERTopic training does its thing. We rent out hardware, whatever's appropriate, on RunPod, push the Docker image there, and then it will run. We rent it out by the hour. The reason why we don't do it locally, if you are familiar with training models, you already know this. It drains your GPU and CPU, and sometimes you don't even have enough to run on small corpus types. So we rent our hardware out on RunPod or Modal. After the model completes generating, it goes directly into degeneracy detection, where we check for outlier rate and topic count. These are just ratios, so it's a simple math equation on the outlier rate that we expect. Usually that's a prefixed percentage of 35 to 40%, depending on the size of the corpus, and then topic count, which is based on the document density and document quantity. This is our expected document count. If it's too small or if it's too large, it fails, and then it gets passed to a small reasoning model like Sonnet 4.6. We pass the failed results, the corpus type, and other subjective criteria to an AI model, and then it will determine what parameters to correct, and then it will pass back that same corpus, load it up, set the configurations properly, and then train again, and it will go until it passes. That's one of the main innovation loops in this topic model pipeline, is that when you're running long running processes, so say it's the Navy and we have 17 different shards, or if it's the Veteran Affairs, and there are 32 different shards, if shard 17 fails, doesn't pass, the whole process doesn't fail. It just reconfigures that one shard and then goes again until it completes. Once it completes, we do an outlier reduction pass, which just is a few simple equations to reduce the amount of outliers that are in those topics. So what BERTopic does is, instead of having these awards or SAM solicitations grouped by NAICS code or product service code in a government procurement sense, it just receives the descriptions and has to discover those grouping names. That's the innovation of BERTopic, is it discovers topics within language corpora. Okay? Now imagine it discovers 7 topics within 10,000 documents, and there are 2,000 outliers, right? So we have 7 buckets, we have 10,000 documents, but only 8,000 of those 10,000 documents got put into the buckets. We have some outliers. There are a few simple algorithms, techniques, and methods that we use to push those remaining outlying documents or artifacts into their buckets using cosine similarity with the topic labels and other various techniques. If you want a video made on that, we can do that. It's a pretty special part of our process. Same with shard unification. So like with the Veteran Affairs or the Navy or Army or some large corpus, we have to unify each topic model. Okay, so it's the same agency, the same award document type, but there are different segmentations of it. So we might have 10 different models that we have to unify. If you guys want a video made on that, I could spend 20 minutes explaining how this part works. The reason why it's outlined in yellow is some award corpuses or corpora, like NASA, for example, that are only about 90,000 documents, that can get passed as a single corpus into the topic model pipeline, and then it doesn't need this shard unification step and instead just goes directly to model persistence. Okay? So, after the model persists and is stored, it is then measured for coherence and diversity. And you might ask yourself, Nathan, why do you store the model before testing its coherence and diversity. Well, kind audience member, that is because we can audit breadcrumbs from our growth, from where we started. We see what works. It's the same reason why a scientist keeps documents or logs of their experiments. Every single time we generate a new topic model, we save it because it's a part of our larger experiment. We can learn from past mistakes, things that have worked, patterns, blah, blah, blah. So again, if it fails coherence or diversity, then it goes up to this model again. It's passed to the reasoning model and it says, this is why it failed. Here's some criteria about the corpus type, and then it will go up into the model again and run that loop. So there are two loops within this system. There's the degeneracy loop, and then there's the coherence and diversity measurement loop. And those are the two major core innovations of our topic model pipeline, and that is just so it stays alive and running on failures. Here are these two little output products. We get trained models, we get topic metadata, we get evaluation metrics, and we get cross-corpus alignment. We will talk about cross-corpus alignment in the next video, where you can see here there's a more complex process for that afterwards. So this, after we run it on all of our text, we usually come out with, I don't know, I think we had like a couple hundred models, topic models, that we then pass through this topic alignment thing to create canonical topics across agencies and then canonical topics across government. So